Okay. So, have you ever hugged a mainframe? Have you ever learned something new when it comes to coding? Have you ever had a person help mentor you to code something? And I had this experience 47 years ago. I grew up in the shadow of Bell Labs, and some adults took some kids, I was 11 years old at the time, and had us learn how to write our first programs. It was on a mainframe. PCs weren't invented yet. A couple years later, they were, thankfully. But I mention this because we're all learning new things every day. To be good at what we do, we need to be lifelong learners. And much like Django Girls and the Humble Data, it's okay to be a beginner and to get help to get started. I know I spent a lot of time over a decade ago in San Diego just helping people install Python. And thankfully, it's a lot nicer now, but it was a little challenging then. So today, I want to talk a bit about AI, about Python, and heuristics, which is a fancy word for rules of thumb or just ways of doing things quickly because you already have like a sense of what it is. On the subject of AI, it also has a tie-in to mainframes. When I was 21, I started programming some expert systems and learning about neural networks, and that was in probably 1988. So AI is not as new as the hype around it might seem. It's actually been around since the 1950s. So for today, what I'd like to do is welcome everybody to EuroPython. I'm incredibly humbled and honored to be amongst all of you, and shout out to the people that are joining us remotely. I've added a QR code and a link if folks want to pull down the slides for a few reasons. One, I can sometimes talk quickly, so it might be helpful if English is not your native language, that you are able to use the slide deck to translate, or that you don't need to copy down links that I might have sprinkled throughout the presentation. So for all the creators, Python explorers, teachers in the audience, I know that all of you have different goals and different experience levels. So whether you're new to Python or have decades of experience, my talk's goal today is your success with Python. Specifically, I hope to leave you with some tips and ideas that I've gained over the 47 years I've been programming, and that you can apply to your work. And with that, Yulia did a lovely introduction. And I'm really proud of these things, but they're not necessarily all of who I am. Yesterday, I had a chance to talk with Nicholas and Josh, and I watched an old EuroPython talk that Nicholas did. And I realized over the last 3.5 years when I was working as VP of Engineering of a startup, that I got really far away from my passion, which is creating tools to help build access to learning and to empower people to do so. So that was me when I was programming my first personal computer, and some friends, and that was me graduating for college. And one of the things when I graduated as an electrical engineer, I thought, oh, I should get a PhD in engineering. But at the time, what I felt like was a broken, isolated, stupid failure. I was the only woman interviewing for many PhD programs, and I hadn't found my place. And this amazing mentor who coached me, encouraged me to attend MIT, not as an engineer, but actually in their management and applied economics program, but also being able to use things like artificial intelligence. And I owe Margaret so much. We still stay in touch today. She sends me messages about how to teach Python to her grandchildren, and it's been a special thing to have a mentor like that. This was me building some voicemail systems, those annoying things that would answer the phone for you. I'm also a mom, and I actually took a 15-year break from tech. And I mention that because oftentimes there is a myth that if you take a small break from tech, that you've lost all your skills and you can never come back, or you have to come back at a junior level. And quite frankly, I think that's BS. That's not to say that you don't have to work to maybe refresh your skill set, but honestly, the only things that really changed from that 15-year period, and I was doing a little consulting, was version control. When I left, it was RCS and CVS, even before Subversion. And when I came back, there was this thing called Git, and Southern California Linux Expo would run these workshops, and the only workshop they had on Git was an advanced Git workshop, which I took and was like, this makes no sense to me. But I was glad that I took it because it helped me understand how Git works under the hood. I'm also a daughter. This was my mom with my kids in 2005, right when she had gotten diagnosed with Alzheimer's. I'm a lover of nature. San Diego Python, near and dear to my heart, and teaching workshops there. Fab Lab San Diego was a place that I volunteered my time. It was a community makerspace, and we helped people build their ideas, and super fun. So my blinky hardware lights and things really came in handy there. I'm also I'll call myself a musician, but even though I've done it for 17 years, I still consider myself a beginner, but it's super fun. I've got friends in the scientific Python community. I've gotten to play with Circuit Python at Adafruit, and Lamore and I got to hack together several times, and there's a funny story for another day behind that, but basically, before she was famous as the creator of Adafruit, she wrote these great posts about how to build electronics and how to go dumpster diving for electronics parts. And somebody said, Carol, you got to see this because you would love this. And in fact, I did, and reached out to her, and we've had a relationship since then. Python Brazil, these PyLadies, absolutely phenomenal, and really embrace who we are as a community and what we can accomplish working together. PyLadies, as well as Django Girls, really sets people up for things maybe they didn't even think were possible. That's Fernando Perez. He is the creator of IPython and the Jupyter notebooks, and I've been incredibly blessed to be able to work closely with him. I've been able to create notebooks that allow me to help people learn. Jupyter Hub, in particular, was something that I'm really proud of helping develop because it gave people a way to have a notebook without having to install anything. And at the time when we did this, I think we started it in 2016, it was very hard. We were kind of going through the Python 2 to 3 transition, and installing scientific Python packages were hard. So this actually made it accessible to many more people. I also, at Cal Poly, when I was working there, helped give back in terms of mentoring some middle school and high school students, much like was done for me. And, you know, on a pragmatic note, being a woman in open source, being a woman leader in open source is sort of a rare thing. And the reality is there will be naysayers. And resilience is something that is super important. So I encourage all of you to use your superpowers proudly. And with that, I'm going to shift to the journey that I'm going to take you on today. And it's really, I'm deathly afraid of heights. And so why I chose the mountain climbing, I have no idea. I think it's because somebody posted in the Slack that they were going mountain climbing here. But, you know, we're gonna start there. And, you know, I would be pretty scared to try and go to the top. But what I'm hoping is that by the time we're done today, that you'll have the confidence to look at coding and development in a different way. And that you'll be able to tackle the dynamic world that's changing around us, that you will use Python to make your code better, more effective, more understandable, that you will have a new appreciation for AI and how that might help you on your journey. Heuristics, rules of thumb, super, super useful. And, you know, with any luck, you will have some new tools in your toolbox at the end of this talk. So let's get started. So we live in a dynamic world, and change is the norm. There's speed of change, complexity of new things, and oftentimes it can feel a little overwhelming to try and deal with change. On top of that, there's a lot of global issues: climate change, health, poverty, food sources, global economics, and these problems are going to be solved in part with code, but also humans. And so as a developer, you may be sitting there today or tomorrow or a month from now and be faced with decisions like, what should I learn? Which tool is the best one to learn? How do I use it? And when do I use it? And this becomes even more challenging when we're in the midst of a paradigm shift. And what a paradigm shift is when a new technology comes along and really changes how we work. And during that time, you've got this tension between enterprises, government, and individuals sort of pulling in different directions as to what the best way to use a technology is. And one of the interesting things about it is at some point in that tension, enterprise typically will hype the new technologies that they've invested money in. And there's a lot of hype out there today. Most of you, I would think, have heard not just AI, but large language models, and how AI is going to take over jobs in the world. And, you know, a lot of that hype is just news. And, you know, sometimes with new technologies, there's pitfalls, sometimes there's success. So consider the source of the news, make up your own mind, and recognize that paradigm shifts evolve over time. I've been through many paradigm shifts in technology in the last 47 years, and I think one of the things that's important to recognize is these paradigm shifts happen in years, not months or days. So although the hype makes it feel like you need to do it now, that's not in fact the case. And so I want to share 2 projects that really transformed science. One of them was one I worked on, Jupyter Notebooks, and we started the IPython notebook in 2011. It really hit its stride probably 2016, 2017, and then really kind of skyrocketed from there. We never anticipated that it would have the adoption that it did. I mean, it transformed learning in places like UC Berkeley. In fact, we had a Jupyter Hub running from this picture, and they had 1,000 students taking this first class. And we deployed it, and we hadn't really tested it at the scale that it was being deployed at. So for the whole lecture, we were on pins and needles whether it would fall over. It didn't. We learned a lot about scaling things and eventually changed a lot of the way we did things. But to get to where we're using Jupyter Notebooks today, it took a long time. It took a good decade. Another thing that really transformed science was something called AlexNet. And that was back in 2012. And it was the first time that deep learning was used to generate solutions or be able to identify different objects with different probabilities. And I mention this because this is the founding technology for all the large language model stuff that's in the news today. And so what are we, 2024? So it's been like 12 years since then. So again, it doesn't happen as quickly as the hype might make it seem. So we live in this dynamic world. How do we respond to change? And I'm going to encourage you all to create your own toolbox. Your toolbox will look different than mine, but what I've learned over time, cognitive science is something that I've studied, and really that's just a fancy word for a whole bunch of different things, AI included, that helps people learn and be effective in how they make decisions and how they approach problems. The toolbox that I'm going to share with you today has some Python in it. It has some AI in it. It has some heuristics in it. And I have the prompt that I gave for ChatGPT to generate the image. And I was puzzled as to why it had heuristics in the prompt, why it spelled it with a G. But, you know, it's a good illustration that we're far from perfect with these technologies. So, with that, anybody ready for some Python? Nice. I figured maybe because you're all here at EuroPython, which is just the most awesome conference, and it's my first time, so other first-timers that are here, I hope you have as good a time as I'm having the last few days. So Python has a lot of strengths, and it's a really good foundation, which is probably why it's one of the top software languages, programming languages. I think some of the unique things about Python compared to other languages is, first and foremost, its readability. There's something to be said for being able to read good code. And because oftentimes we will write code, but as you get into the world and working, you're finding a lot of time that you're reading other people's code, whether it's code reviews or you're trying to refactor something, And the readability really matters because what it does is it reduces the cognitive load that you have to deal with as you're working with the chunk of code. Probably not a surprise after the great opening this morning that community support is phenomenal in the Python community. And I think one of the other things that has always struck me about Python is how it's used in so many different domains, whether it's DevOps and scripting or web, science, data science, education. I think we learn from each other in different disciplines. I know that when I was doing Jupyter Hub and Binder, I was looking at other projects that were already using Kubernetes and really taking the learnings of other people in the Python community and applying it to our projects. So I think that is a really valuable thing. But Python gives you a solid foundation. Now, there are some people that will say Python is slow. And I'm not going to debate whether Python is slower or faster than Rust or C. It's just different. And I think there are some things you can do, which we've done in the science world, to improve performance. First and foremost, stay up to date with the releases. Pablo and many of the other core developers that are here have been working really hard for probably the last 6, 7 years to really improve performance. So take advantage of it, use the most recent versions, try out the experimental versions. Shout out to Hugo, who seems to be everywhere, but who is going to be managing what I'm calling the 3.14 and 3.15 release, but who knows, it could be the apple and orange release. We'll see. So that's step one. Step two, measuring, profiling, and optimizing code. There's a number of different tools that we can use to do that in the Python world. And I'm not going to go deep in any of them, but I leave this here for you to take advantage of the talks that are here, as well as online, to learn more about it. I do want to highlight PySpy, which I thought was particularly interesting because it lets you profile on a running process. So you could actually use it in production. And Anthony Sotili, where are you? Somewhere in here. I met him earlier today, has an amazing YouTube explanation of how to use PySpy, what the benefits are, and so the link is there. He's also in the audience, so if you're interested in it, I'm sure he'd be happy to chat about it. So another advantage of Python is that it's polyglot friendly. By that, I mean it can use different languages. And in today's world, one language deployments are rare. Usually there's some mix of TypeScript, JavaScript. We might want to use some Rust to get either performance or just a new way of doing things. Pydantic, there's a lot of people using that, and we've been using it we were using it in production since pretty much the start. Playwright, if you haven't tried, PyTest is great. And Playwright can work alongside PyTest, but it's a testing library, and it does JavaScript, it does Playwright. Andy Panda has some great talks about it, but it's well worth trying. The learning curve is pretty shallow, and I would encourage you to take a look at it. We've been working probably since 2017 on modernizing the web and how Python interacts with that. We had the WebAssembly Summit here the other day. There's a lot of projects out there that are really enabling us to offer things that we weren't able to offer in the browser 5 years ago. I teach a lot of youngsters, and so on my personal website, I have Jupyter Lite running in the browser so that they don't need to install anything and they can get up and running. And so it works with kids, it works with adults. It took me maybe a half an hour to deploy it. So the instructions are really good. We are also modernizing mobile. Russell Keith McGee has done great work with the Beware project, and we've had 2 PEPs in this past year that make iOS a supported platform and Android a supported platform for CPython, and I'm looking forward to seeing where this grows over time. Python is also innovating things, and some people might say packaging is innovating things. There's a lot of different tools in the packaging ecosystem, and we had a really great packaging summit at PyCon this past year. It was very collaborative, and we started talking about supporting both producers and enabling consumers. And by that I mean producers use tools to package their code so that they can then distribute it to others, for others to use. And there are tools that folks need for that may be very different than somebody who's consuming those libraries and packages that are out there. I think we're at a really interesting place. I think it was probably a decade ago when we sort of had the pip conda, battles, and, because we were sort of shifting what Python was being used for and the fact that different groups had different needs, it was too hard to bring it all together. I think now with things like Rye and Pixie, we have the way not only to make somebody who's using Python packages more successful, but also maybe converging on a better story for how we do packaging. Less about the tools and more about, okay, these are the steps that will help you be successful. User success, super, super important. From the developer experience to how to teach new features in Python, improving accessibility. All of these things are really important. Bernat I saw a talk that he gave about maintainers and contributors and the lessons that he's learned a few months ago. It was phenomenal. He is also giving that or a similar talk here. So I highly encourage you to check it out on the schedule. It was the best maintainer talk that I have seen, and I've seen a lot of them. So to recap, Python gives you a solid foundation. There's strengths, performance that you can get, and when you need maybe a little bit more, go ahead, use Rust and C++ or other things to kind of accelerate the things that you've profiled that maybe you do want to improve. And that's pretty impressive for a 30-year-old programming language that it's still innovating. So let me turn to AI. And on one side here is an actual C star. The other, it was generated by AI. The one on the left has a lot more definition, maybe more beauty. That's subjective. The one on the right looks more kind of, I don't want to say fake, but it doesn't really look like a real C star would look like in nature. But pretty impressive. Now, here's another set of images. One is a photo, One was generated by OpenAI, and the prompt was create an image of a woman with late-stage Alzheimer's. And my mom is the picture on the left, and that was 1 month before she passed away, versus the one that was generated on the right. And I share this because what gets generated, you kind of have to go through the ABCs. Is it accurate? Is it biased? And what conclusions do you draw from what has been generated? My mom was super pleasant and sweet throughout her lifetime. Even when she had lost all verbal ability, she could still enjoy music. She still enjoyed like holding the ball of yarn or the puppy dog that she has there and getting that tactile sensation. So as her neural network was remapping or changing, so was her personality. And I have to say, I was really surprised at how dark and stark the image on the right is. So the ABCs of AI is a tool. It's not a person. A person chooses an AI tool to use. And an AI tool is just that, a tool. It has limitations. Much like if you were building something in carpentry, you want to fit the tool to the job that you're trying to do. And you want to minimize the harm done by the tool. If I was working on like a bracelet and I needed a hammer, a sledgehammer probably wouldn't be the best hammer. It'd probably be a smaller one. And probably using a screwdriver to bang in a nail wouldn't be all that effective either. So I want to leave you with some ways to learn about large language models and to sort of demystify the black box that they are. And one of my friends, Jeremy Howard, has a wonderful YouTube video that he explains what a large language model is. And those illustrations in the middle there was the next step after AlexNet. And it was work that he did. So he is very experienced in this. And this particular video, it hasn't been up that long, has 500,000 views. So highly encourage you to check that out. So we often talk about open AI, not the company, but the concept of open source AI. And I think it's sort of a misnomer. And so I have often started calling it transparent and trusted AI because I think there's too much of a tension between people and profits and needing to consider the incentives that each group has, what the cost of things are. At Oxford, they're doing some great work with AI ethics. So if that is something you're interested in, do check that out. But being transparent about code or how we've built something is what builds trust. And trusting the tool, you have to consider the source. Is it fully open source, partly open source, closed source? Explainable AI, it's not good enough just to explain what the code is doing, but to really understand what's going on, you need the data, the infrastructure, processes, the governance of the data, and there's a great, if you want to learn more about explainable AI, there's a great awesome AI, explainable AI thing on GitHub. The other thing that just came out was there was the first major study of generated misinformation. And for those of you that have been working with large language models for a while, might find this really interesting because it was enlightening how much misinformation could be propagated fairly quickly. Another project that my friend Jeremy Howard did was Claudette. Anthropic has a model called Claude, which is very useful and very user-friendly. And one of the things I've liked about both Anthropic and Claude is they've tried to be more transparent about the tool and different ways of using it. So they have a gallery so you can like try different applications of it. But basically, Claudette relies on notebooks, and it wraps the Claude API so that you can break out of the Claude user interface. And what this does is it ironically removes some of the complexity and the boilerplate, and it makes AI easier to understand. It also is interesting because of the fact that the notebook is such a great communication tool as well as computation tool. And Jeremy has a really interesting way that he builds things. He actually builds code through the notebook that he then packages as a Python file. And it's kind of an interesting way, and a way that I think will ultimately help people understand more of what's really going on with these models, and also give people a way to contribute to these projects. So understanding, at the end of the day, is what's key about AI. We are all data people. There's data all around us. We are sharing data all around us. And Brandeis Hill Marshall is somebody that I read a book and spoke with her last year, and just has a really great way of how to teach these concepts to people who aren't computer scientists or coders, and it's going to be important for everyone to understand what is the impact of these tools. Now, you might think, from hearing what I've said so far, that I'm not a huge fan of AI and large language models. It's actually not true. I think Chan Zuckerberg Initiative is something that I've sat on their Open Science Advisory Board, and I see phenomenal things being done with mapping a cell, looking at drug interactions where you can use the large language model sort of as an intelligent brainstorm partner, where it can surface ideas really quickly. So a researcher can then say, nah, I don't think so, or maybe, yeah, that maybe is worth using. And my hope is that because of the way that these tools could potentially accelerate learning and decisions and idea generation, that it will take us closer to solutions for different health and diseases that are out there. So to recap, LLMs are tools with trade-offs. And I highly encourage everybody to play around with them if you haven't already. It is kind of interesting, but have a critical eye and think about, okay, is this really doing what I think it should be doing, or is it putting a G in heuristics? I don't know. So heuristics are things that save us time. They are based on our real world experience. They're super useful when information is unknown or overwhelming. And they're very easy to apply. So you're already familiar with a number of software development heuristics. And you aren't going to need it. Code that you don't have doesn't break. So there are no bugs in it. So, that's a good rule of thumb. Don't repeat yourself is something we'll hear often, or incremental development where you do feedback and make adjustments. But there's also a really Pythonic heuristic, and that's called the Zen of Python. So for those of you that might be newer to Python, if you type import this on the command line, it will give you these, I don't know if it's a poem, but ideas or concepts about what is Pythonic. And I think it's really valuable. In a lot of cases, they are really good heuristics. I had the opportunity to moderate a panel with several language creators, and I do remember from the discussions with them, a lot of the decisions they make are based on heuristics. They're based on the patterns that they've experienced in real life over time. And so I want to share another tool that is related to heuristics, and that's called Scamper. If you have to solve a problem and make decisions, to overcome obstacles, this is a super useful effect. And I'll give you an example. I spent a year as VP of engineering at a startup. I had been at the startup for 3.5 years. The technical design was not mine. It was overly complex in its real-time collaboration feature, which resulted in it being difficult to predict the behavior because of the concurrency, and resulted in a lot of outages. Now, what I did was apply some of these ways to get over those obstacles so that we could get, after 2 painful months, better stability. So I combined observability with some of the things that we already had. I had them eliminate some of the problematic features and substituted tracing for error handling that we had in other places, just so we could have a better understanding when things failed, what was going on. So learning is all about how you gather information and process it. And the human mind works in a very different way than a computer. A computer, you read stuff in, you take stuff out. Your brain as a human is actually chunking information and making connections between that information. And there was a great talk that happened at PyTexas about what is Pythonic code and how even an experienced programmer might struggle when they come to Python. And it's for the fundamental reason that experts and beginners approach problems differently. Experts recognize the problems. They see the patterns. They've experienced the patterns. Where beginners, when they face unfamiliar code, are really like trying to figure it out line by line, which is cool. That is the way you get to recognize it down the road. But it's a really interesting talk, and the paper that's linked is also really interesting. It's 10 things that software developers should know about learning. So we've gone through Python, we've gone through AI, we've gone through heuristics. Heuristics are something we use every day and probably don't even recognize that we're using it part of the time. So now you think about how you can use some of the tools that I've already suggested in your own work, either now or in the future. And I encourage you to curate those tools often, because the challenges we face are complex. We have changing requirements. We need to make decisions, and sometimes it's scary to make decisions. And we want to be confident in how we do that. And we want to make sure that we're impacting the human outcomes in the correct way. So my call to action for you is relax and adapt and thrive. Whether you're got the whole set of rubber ducks here, which was actually at the European Weather Agency that does forecasting for, and I thought it was pretty cool, like kind of, I don't know if you'd call it a statue, but, or you're leaning on your peers in the community, you don't have to do it alone. It's okay, and you should expect to make mistakes. When my son was learning trombone, they would often say, adopt this musician's mindset. So you're going to make mistakes, you're going to hit the wrong note, just be loud and proud in how you do it. And I think there's something that we often overlook when it comes to mistakes, and that's mistakes give us feedback. It gives us information, and it gives us knowledge. In fact, most scientific research is a series of mistakes that finally you've learned enough that you then can determine that this is the way you should do something. One of the most important things that, and lessons I've learned over time, is to really value your time and energy and follow your path. A lot of people might say, you should be doing this or you should be learning that. We're all different and we have different needs. And I want to encourage you to take what you know and go out and impact the world around you. Donald Knuth was, or is, a Turing Award winner, wrote that big stack of books on the art of programming. And he had an interesting quote in 1984 that also was what we used to inform how we designed Jupyter Notebooks. And that was, instead of looking at how to instruct a computer to do something, maybe we should concentrate more on explaining to human beings what we want the computer to do. And with that, I want everyone to remember that fun builds resilience. I would not be here after 47 years of programming and 58 years of life if I was not having fun doing this. And one of the things that's really cool is you're here at EuroPython. There's some really cool, fun stuff here. I really encourage you to enjoy it. Thank you so much for listening to me, and have a great rest of the conference. And since we all want the coffee break and we're kind of at time, I'm going to be around through Saturday. So if you have questions or want to chat, please come up to me, and I'd be happy to do so. Thanks.